All right, as promised, we're gonna go over the new MSA 5X gas monitors, and I'm gonna compare them kind of with the old ones, the Altera 4XRs. So they're both MSA products, same sensors as before. We have 3 sensors. So in the old style, the sensors are right here. One's a combination sensor for toxic gases. So we actually monitor 4 different things, which we'll go over, but there's only 3 sensors because one does 2. The difference between the new monitors and these old ones is these ones are diffuse monitoring, meaning that you have to physically have these sensors in the product in order to get readings, versus the new 5X, which is a little bigger, which has a pump built into it that's right here, and it'll actually draw in a sample. The sample that you're monitoring through that pump, this is a 20 cc syringe. So if you could think about drawing 3 syringe fulls volume of air, that's about how much you're pulling in through that pump every minute when you walk by. So the key to monitoring is we still want to be slow, but the benefits of this is you don't have to actively be in the product when you're monitoring. It's pulling in a sample through that pump. And on top of it, we have accessories where we're keeping these stored under the captain's seat in the Ziploc, but it's got Teflon tubing that you can connect to the end of the pump. So if you want to be below grade in storm drains, sewer drains, or Sun River, we recently had an event where the gas leak was behind a bunch of equipment. You could kind of drop this tube off the monitor behind and get better monitoring behind equipment or below grade with these monitors. It's got a little white piece right here. That's a water filter. So if you're monitoring below grade and you were to suck up water or fluid, it keeps it from getting into the monitor itself and breaking the entire monitor. And so to replace that, once again, underneath the captain's seat, we're gonna have these little kits that come with the monitors. And to replace that, if you were to have water inside of it, would be to just undo these 2 screws and switch out this white filter with one of the white filters in the kit. And then your monitor's good to go, it's protected. So, like I said, these 2 monitors have the same sensors in it. They both have 3 sensors. Those sensors monitor O2, CO, H2S, and LEL. So on the oxygen side, the sensor range itself is from 0 to 30%. On the CO, it's 0 to 1,999 parts per million. On the LEL, it ranges from 0 to 100%. And on the H2S, it ranges from 0 to 200. Our limitations for these are O2, you will get a low alarm at 19.5% for a lower alarm limit, and upper alarm limit you get 23%. It'll start to alarm. On the CO, you'll get at 35 parts per million for the lower and 100 parts per million for the upper. To note on CO, when these come from the factory, they're set to alarm lower limits at 25 parts per million, so that's why some of the literature says that. I went in and reprogrammed it to be 35 because it's going to align and match up with our CO policy coming up of when to be cognitive for SCBAs, masks, all that stuff. That's also the short-term exposure limit, which all these parameters line up with, which means that in the industry setting where these monitors were created, 8-hour work days, 40 hours a week, those are the levels that people are able to be in those atmospheres at those lower limits without having long-term effects. So our safety buffers are based on occupational work because we don't expect to have any findings in general residentials. H2S, hydrogen sulfide, decomposed materials. The alarm limits are 10 parts per million for the lower alarm and 15 parts per million for the upper alarm, which cues you in that that's a super toxic substance because there's a low parameter range for those alarm limits. And like I said, the H2S and CO being the toxic gases are 1 sensor, so they're measuring both, which is why you have 3 sensors, not 4. These MSAs, the new ones, in the literature you may see that there's more gases you can monitor. Ours aren't capable because we only have those 3 sensors in it. It does have a spot where you could put in another one if you had a high target hazard, like you worked in a place that had lots of a specific chemical, you could get a monitor for that. But we don't have that, so when you read the literature, it's not accurate. Ours are the same sensors as the old monitors. They just have the pump. So going through here, same startup procedure, just hold the power button on. It's gonna alarm, and it's gonna go through the settings. The reasons monitors take a while to warm up is because that LEL is like an electric stovetop grill. So it's heating up that sensor, so at a microscopic level it could do combustions to see what the LEL atmosphere is. And so it's going to cycle through. The difference between the new one is you'll hear that beeping and pump test. Since this has a pump, it's asking that you cover this to clear it, and all that's doing is checking to make sure that the seal right here isn't broken or cracked and that it's actually drawing in a sample and reading through your monitor. So it's going through the 4 different types of sensors. It's going through the lower alarms, the upper alarms that we just talked about, the limitations of what they're set at, short-term exposure limits, time-weighted averages, and those are all in here as you cycle through. We'll go through that. It's going through what it's calibrated off. We use a pentane blend mixture, which uses methane for the combustion part, and the rest of the mixture to measure the limits within. Here's that warm up of that LEL sensor and all the other sensors. And then it's ready. It'll prompt you if you want a fresh air setup. All fresh air setup is making sure you're in a clean environment. If I were to hit yes, and it's just running exactly what it says, fresh air over the sensors to clear out whatever residual they have on it. You see a bump test and a calibration. We often confuse here bump testing, calibrating, so I want to get the record straight that bump testing is more of an industry thing. It's just testing to make sure that the monitor detects the 4 things it's monitoring for. Is it detecting O2? Is it detecting LEL, CO, H2S? We calibrate because we don't work in the industry setting and we do it once a week. And the calibration is making sure not only does it detect those 4 sensors, but does it detect it within range so that when you're monitoring and measuring, you're actually getting an appropriate reading of what's on here within range. LEL is 10 to 20%. It's because every chemical, if you were to take NIOSH, for example, the guidebook will say gasoline because we're familiar. It's got a LEL and a UEL. That stands for lower explosive limit, upper explosive limit. So anything below that, it's going to be too lean to burn. Anything above that limit, it's going to be too rich to burn. At 10% of this 1.4% for gasoline example, that's when you're going to alarm. At 20%, you're going to be alarming on the upper limit. It's because at 100%, you'll see triple X, meaning that you're in an explosive environment. And that triple X means that you've hit your 1.4%. And anything within this range for gasoline specifically, you know, different chemicals have higher ranges, that threshold is alarming. So since it's not linear, we don't know how many steps is difference between 10, 20, 100. It gives you a lower alarm at 10 and an upper alarm at 20 to build in those safety factors. CO, like I said, with the new SOG coming out, 35 parts per million is what people work in industry, 8 hours a day, 40 hours a work week. 200 parts per million, you start having effects, and that's when you start having to make sure you're packed up. We once again have those safety and buffer factors for alarm limits set for CO. O2, 19.5, 23%, those are your parameters. And then H2S, at 20 parts per million, you have immediately dangerous life and health, permanent deficits, you stop being able to smell. So that's why those parameters are super low, 10 and 15 for low and high. So these monitors, going back, and it's the same for the new one and the old one, they have 3 different light indicators. Red, which means it's either charging or it's alarming. When it alarms, you have a visual, you have the red light going off, the vibration, and also the audible noises going off. Yellow means there's a fault of some kind. You could get that during charging, during calibrating. And if you were to get a fault, try to recalibrate again, start from the beginning. And if you get it again, then that monitor's out of service. So give me an email. And you also have the green, which just means it's good. Sometimes you'll see monitors light up blue. They can be dropped. We don't do it, but people drop them in hot zones to monitor remotely. So that's just the Bluetooth setting reading in the background. If it is flashing blue, it doesn't matter. It doesn't affect our readings or monitoring. On startup, you'll see one of these might be flashing when you first start it up. Any button, right one, will give you a backlight, by the way. But if you notice there's a heart icon, that means that one of the sensors is approaching its end of life. And so if you were to start this up again during startup, you'll see something flashing. So in this case, the CO will be flashing. That's because it's the CO sensor that's approaching its end of life. That's super helpful for me in repairing and ordering parts. If in the email you could say, hey, we have a monitor that's approaching end of life, it appears it's the CO that's flashing. There's a spec sheet for these that Pause was kind enough to create, and this lives inside the Q drive underneath equipment. There's a folder for equipment and apparatus, and then in there's the MSA 4XR, which is the old style monitors, and there's this new spec sheet which aligns with the 5X for reference. All right. So like I said, these are gonna go here underneath the captain seat. And then for charging, currently we have the old style ones that are in the vehicle cradle. These new ones have a cradle specific to them. They don't fit in the existing cradles. So temporarily, we have a charging cord run from behind the officer seat and the power supply up. The thing with that is you only get a charge on the new monitors when it's plugged into a shoreline. But as they go in for maintenance, the shops are gonna install cradles in place of the old ones. So those old ones are gonna come out, and where it's currently charging from for the new style monitors, it's the same one. So we're gonna just plug in the old ones here as a backup. That way, if you go on gas leaks, commercial, you just want a secondary reading. We have two monitors. If one goes down, we need to maintain it. We always have a backup monitor. So with that, we're gonna keep the same setup cord, but our primary is gonna be the new style 5X monitors in the charging cradles. Runtime on those, stand corrected on my email. I said 24 hours, I believe. It's 12 hours at 70 degrees. So that's kind of a guideline, which is why we want to get away from being just shoreline on the main ones. And we're swapping out when the vehicles go in for maintenance, the shops will install the new cradles for where these charge. So when you're starting these up, this is the volume, just so you know, if you want to cover it, if you're in the back, so that you don't have a bunch of beeping going on at startup, you can hear radio traffic. To calibrate these, sake of time, that's the screen of what it looks like after it is done and it's successfully passed calibration. This green ring, it just tells you that the calibration bottle is good. It's basically measuring expiration date. So if this is red, you don't have a calibration system that's ready to be calibrated, but it's green, it's good to go. You need to turn it on, and you don't really need to do anything else. If you wanted to force calibration, there is a button right there for calibrate that you hold down and you can force it to calibrate. But by putting it in the machine, it'll calibrate automatically. The big thing on these is just, you flip it away from you, it's got this little port. You just need to make sure that the pump pushes up into that port and locks. And then the screen will take a minute, and then it'll start auto calibrating, and at the end you'll see that pass green banner, and you'll see it in progress right now. Just like our old monitors, it'll take a little bit. At the end of it, it'll give you the option to fresh air setup again, which means once again you're going out in a clean atmosphere, just running air over the sensors and diluting it with whatever's residual on them, so you don't have those 1, 2 readings that are residual. So I want to just explain one additional principle, and I also want to side note that for chlorine or ammonia, those are extremely corrosive chemicals. We should probably know if we're going into that atmosphere, but if we are trying to use a 4-gas monitor of any kind, you can't, because it'll corrode the circuit board because it's corrosive and give you all sorts of faulty readings, and it's not good guidelines. So pretty much we just use monitors for corrosives as exterior perimeters to make sure our zones are identified. But going back to this principle, I just took from the NIOSH guide again, ethylene oxide. And I'll start by saying ethylene oxide is used in hospitals as a sterilizer. A lot of people will be like, oh, we're never gonna see that. Well, it's actually pretty common because it's extremely toxic and it's extremely explosive. So it works really good as a sterilizer and really good for burning off additional stuff. So back to this. If you look at these monitors, which measure in parts per million, right? So you take 1 million parts and you multiply that by 1% as a decimal, 0.01. For every 1% reading you got on, say, LEL, you're getting 10,000 parts per million of something displacing that. So yeah, we do measure only 4 specific gases on these monitors, but anything that is displacing oxygen may not be CO, H2S, LEL, but you're getting a 10,000 parts of something else to displace to change the readings, right? So if we're just waiting for our monitors to alarm at the lower limit of 10%, we'll take ethylene oxide, for example. It's got an immediately dangerous life and health, meaning you'll have irreversible damage to your body at 800 parts per million, and Ca in front of it means it's a cancer-causing agent. So that's a really low part per million threshold. The LEL and UAL range from 3% to 100%, showing that it's got a high range of flammability. So if I'm monitoring on here and just waiting for my alarm to go off at the lower limit of 10% of that 3%, if you take 3% and multiply that by 10,000 parts per million for every percent displacing, right? You have 30,000 parts per million. At 10% of that LEL 3%, you'd have 3,000 parts per million. So by the time you get a lower alarm on here, showing you that you're in a flammable atmosphere, you're already dead from the toxins because this is 800 parts per million. And I bring this example because I think we get in the habit of waiting for our monitors to alarm or beep or do something to see that we're safe. But really, we shouldn't expect any changes inside a residential or commercial to that extent. So always be cognitive of any changes on your monitor because it's telling you that 10,000 parts per million are displacing that reading. And depending what that chemical is, it could be super dangerous.